So given that we very rarely get to record from individual neurons in humans, and we want to know more generally if there is an MT in humans, what do? We pop subjects in an MRI scanner, and we show them moving dots or stationary dots. And we scan them with functional MRI. We'll go through the details of how this works more in future lectures, but what you see basically is this is a slice through the brain like this, and you see this region right here responds more to the moving dots. This is a response to, this is time here. This is when the moving dots are on high response, and then when it switches to stationary dots, the response drops. Okay, so with functional MRI, you can also find visual area MT by the higher response to moving than stationary dots. Does that make sense, more or less? I mean, I'm not giving you any of the details, but for now, they don't really matter. Okay, so that's cool. But does that tell us that neurons in human MT are specific for the direction of motion? Yes?
Are the moving dots moving in a specific motion?
They're moving in all the directions you see here. No, it doesn't. It tells us it's sensitive to the presence of motion, but not the direction of motion. Okay? So if we want to really know, is human MT like monkey MT, or is this really human MT, we want to know, are the neurons in there not just responsive to motion, but are neurons specific for particular directions of motion? Okay? So how would we do that? Okay. Well, there's lots of ways of doing that, but actually one of the charming things is you can do that without an MRI scanner. That is, it won't tell you whether it's MT you're looking at, but we can ask the question of whether your brains have neurons that are tuned for particular directions. So for this demo, I want you to fixate right in the center, and do not move your eyes from that dot. And I'm going to keep talking for a while you keep fixating right on that dot.